first reaction to the question, we see solve, so it's not prove. So we can do things to the equation one side to the other. But here, again, it's important that you have that formula kind of memorized. I see cos plus sine. And so what you have to have is like, hey, does that match up with one of my formulas? Cos plus sine, yes. If I look on my formula sheet, I have that cos of alpha minus beta is cos alpha cos beta plus sine alpha sine beta. Okay, next year AP Calculus, they don't give you these formulas. So then you would have to know them from memory for AP Calculus. So cos plus sine is cos alpha minus beta. This matches up perfectly with this being my alpha, this being my beta, this is my alpha, this is my beta. So I can take that left-hand side and rewrite the whole thing as cos alpha 4x minus beta minus x, which then just becomes cos 3x equals 1. A lot of doing really well in mathematics is knowing stuff well enough that it triggers something. So I had to know this formula well enough to trigger me to look at my formula sheet to change it. Then, once I changed it, I get this new equation. This should be another trigger for you. What kind of equation does this look like? Have we done these before? Did we give them a name? Because if you give them a name and you remember the name, you probably remember how to do it. If you don't remember the name, then chances are at this point you would get stuck and have to stop the question. What kind of question was this? We called it a multi-revolution question. So how did we solve? Okay, so sometimes you know the name, but then also still don't know how to do them. That's a possibility. But if we have a multi-revolution question, what did that mean? Well, first of all, we rewrote the domain for 3x. If 1x is between 0 and 2 pi, 3x's would be between 0 and 6 pi. Oh, and there's, thank you. Notice that there's no equal sign on that one. Then you solve for 3x. Is 1 on your pi plane? 1 is on your pi plane. Cos is your x or y coordinate? X. So that happens at 0, right? Yeah, that's y. X coordinate over here, 1, 0, all the way around, 2 pi, all the way around again, 4 pi, all the way around again, 6 pi, but what do we do with 6 pi? We have to take that one out because it wasn't included. So 0 and 2 pi, second time around 4 pi, third time around we'd have 6 pi, but 6 pi wasn't included. Then, if I wanted to find out what x is, I take each of these and divide by 3. And that gives us a final answer between 0 and 2 pi. But if we don't recognize the formulas, or we don't recognize the ideas, then it gets very hard. So we need to do enough practice so we become comfortable with recognizing different things, and then the questions become easier. All right, questions you can circle are 15 and 17. And that gets us ready for example number 5, which isn't in your book, but it is the most important part from this section. So on page 651, you have a complete blank page. Where you can even, if you want, you can even start on 650. Because we're going to do a bunch of questions that are pi over 12 questions. These are the angles on your pi plate, like 15 degrees, 75 degrees. And without a calculator, you're going to be asked to find the exact value of them. And like double triangle questions, it is my hope that you start to love pi over 12 questions, because they are also very predictable, always the same. So if you get good at them, you can get them right every single time. A lot of questions in chapter 6 are somewhat unpredictable, not always the same, which makes them a little bit harder. So what are we going to do for pi over 12 questions? Here is the strategy. Here is the idea. We're going to use the pi plate things that we know. I know pi over 3, I know pi over 4, and I know pi over 6. And for each of those, I changed them so they would have a common denominator of 12. Pi over 3 is 4 pi over 12. Pi over 4, 3 pi over 12. And pi over 6 is 2 pi over 12. Then we're going to see if we can add or subtract them to get the angle that we're looking for. Can you see a way that you could subtract to get 1 pi over 12? Can you see a second way you could subtract to get 1 pi over 12? Yeah, you could either do 4 minus 3 or 3 minus 2. So with these questions, you often have more than one right option of doing it. And we don't have to just use the ones in quadrant 1. We'll be able to use any family member that we'd like. Is it all right if I scroll down to here? So then, in our question, cos of pi over 12, you just need to pick 2 of them that reduce. So if I took 4 pi over 12 minus 3 pi over 12, those subtract to be 1 pi over 12. And if I reduce those are both on my pi plate. Pi over 3 minus pi over 4. So my alpha is pi over 3. My beta is pi over 4. Here, we know what alpha is and we know what beta is. So unlike the survey that we did earlier, this time when you plug it in, you know alpha, you know beta. So we'd have cos alpha, cos beta, plus sine alpha, sine beta. And this is just using your formula. And then all 4 of those, all 4 are on your regular pi plate. So we can put in the values. I know that cos of pi over 3 is a half. I know that cos of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. To simplify, we need to get our final answer as 1 fraction. Do you see that you would have a common denominator of 4 already? So our final answer will just be a root 2 plus a root 6, all divided by 4. And that's pi over 12 questions. So pi over 12 questions, you first have to find two things that add or subtract to get what you want. And the two things that you use have to be on your pi plate. If they both are, when you use the formula, you get four things that are already on your pi plate, which means you can get numbers for all four of them. And then you can simplify, and you get a root 2 plus a root 6 all over 4. So let's do the second one. The second one, can I scroll? Did everybody done writing the first one down? Almost? Okay, let me know when you're done. All right, here we go. So the second one was in degrees, which happens to be, if I change it to radians, 75 degrees happens to be 5 pi over 12. So it is a pi over 12 question, but you can do them in degrees as well. 75 degrees, can you think of two things that add or subtract that are both on your pi plate? Can you see that you could do 45 plus 30? And then 45 would be my alpha, 30 would be my beta, and I can plug that all into my formula. Each of those I can figure out, and I get a root 6, a root 2, and a 4 again, which is kind of cool. I'll tell you this, for sine and cosine, for every single pi over 12, you will always get a root 6. You will always get a root 2. It'll always be over 4. What's going to change is sometimes the root 6 is negative. Sometimes the root 2 is negative. Sometimes they're both negative. So depending on where it is, that changes. But for sine and cos, you'll always get those three numbers. Kind of nice. If you've done enough of them, you recognize that. Tangent's a little bit different. Tangent will get a bunch of root 3s. Always tangent wants to be different, hey? Come on.